The strangest true stories in space history. Have you ever looked up at the night sky and wondered what you're actually looking at? Because when you think about it, the night sky is pretty ridiculous. You walk outside, look up, and there are hundreds, maybe thousands, of tiny points of light staring back at you, and your brain goes, oh, pretty stars. But those little dots are actually enormous balls of plasma, some hundreds of times larger than Earth, sitting so far away that the light you're seeing may have started its journey before your grandparents were even born. And that's just the beginning, because space isn't just big, space is weird. Really, really weird. There are planets where a year can last less than a week. There are stars that explode so violently they can briefly outshine entire galaxies. There are black holes where gravity becomes so extreme that even light can't escape. There are moons with oceans hidden underneath layers of ice. And somehow, in the middle of all of this, one species on one tiny planet decided, you know what? Let's go up there. And that's where things get interesting. The history of space exploration isn't really a smooth story about brilliant scientists solving one problem after another. It's much messier than that. It's full of failed rockets, bizarre experiments, dogs in tiny spacecraft, astronauts getting sick, computers throwing error messages while people are trying to land on the moon, engineers solving impossible problems with whatever junk happens to be lying around, and one astronaut who apparently decided that the moon needed a little golf. But before we get to golf on the moon, we have to go back thousands of years. Imagine standing outside on a clear night thousands of years ago. There are no streetlights, no skyscrapers, no airplanes, no satellites, no advertisements glowing above the buildings. The sky is almost completely black, and the stars are everywhere. The moon is enormous. Sometimes it's full, sometimes it's a thin crescent, sometimes it disappears completely, and occasionally something strange happens. A bright comet appears, a meteor shoots across the sky, the sun suddenly disappears during the day. If you didn't understand astronomy, these things could be absolutely terrifying, and ancient people took the sky very seriously. The Babylonians were recording astronomical observations thousands of years ago. They tracked planets and eclipses and noticed patterns in the movement of celestial objects. And here's something fascinating. They didn't necessarily understand why these things happened. They just got very good at predicting them. It's a little like knowing that your bus arrives at 8:15 every morning without knowing anything about engines, roads, or public transportation. You know the pattern. And humans became remarkably good at finding patterns in the sky. For a very long time, though, humanity had one major assumption: Earth was special. In many ancient and medieval models of the universe, Earth sat near the center of everything. And honestly, it's easy to understand why. Look around. The ground isn't moving. You don't feel Earth spinning. The sun appears to move across the sky. The stars appear to move around us. So if you were living hundreds or thousands of years ago, the obvious conclusion would be, well, I guess we're in the middle. Then, in the 16th century, a Polish astronomer named Nicholas Copernicus came along and suggested something that sounded completely ridiculous. Maybe Earth wasn't the center. Maybe Earth was just another planet. Maybe the planets went around the sun and suddenly the universe got a lot bigger. This was only the beginning of humanity's gradual realization that we are not nearly as important cosmically as we like to imagine. First, we discovered that Earth wasn't the center. Then we discovered that the sun wasn't the center of the universe. Then we discovered that the sun wasn't even the center of our galaxy. Then we discovered that our galaxy wasn't the whole universe. And eventually we discovered that the universe contains an almost incomprehensible number of galaxies. It's like the universe keeps moving the goalposts. Every time humanity says, okay, now we know where we are, the universe responds, are you sure about that? But eventually we needed more than our eyes. We needed telescopes, and one of the most famous early astronomers to use a telescope was Galileo Galilei. When Galileo pointed his telescope at the sky, he discovered things that challenged the old view of the universe. He saw mountains on the moon. He saw that Jupiter had moons of its own. He saw that Venus went through phases. And suddenly, the heavens didn't look like the perfect, unchanging realm people had imagined. The moon had mountains, Jupiter had moons, the planets were worlds. The universe was becoming a much stranger place. But if humans were ever going to physically explore those worlds, we needed something that could actually leave Earth. We needed rockets. And here's where another surprising fact comes in. Rockets are much older than the space age. People were experimenting with primitive rockets centuries ago. The earliest rockets were used for things like fireworks and warfare. But eventually, scientists began asking a completely insane question. Could a rocket reach space? One man who took this seriously was Robert Goddard. Goddard was an American physicist who became obsessed with rocket technology. He believed rockets could eventually reach the moon. He published scientific work discussing the possibility. And the press basically laughed at him. Newspapers mocked the idea that rockets could travel through a vacuum. The argument was simple. If there's no air in space, what does the rocket push against? The answer, of course, is that rockets don't need to push against air. They throw mass backward and the rocket moves forward. Newton had already given us the basic physics, but that didn't stop people from making fun of Goddard, and Goddard didn't exactly respond by becoming a celebrity. He mostly kept working. In 1926, he launched a small liquid-fueled rocket. It climbed only about 12 meters. It stayed in the air for roughly 2 seconds, then it crashed. If you watch that launch today, you might think, that's it? But historically, it was enormous. It was the first successful liquid-fueled rocket. The technology that would eventually carry humans to the moon had just taken its first tiny hop, and it wasn't very impressive to look at, which is actually a recurring theme in human history. The first version of something amazing usually looks completely ridiculous. The first airplane looked strange, the first computers filled rooms, and the first liquid-fueled rocket barely made it above a tree. But it worked, and eventually rockets became much more powerful. During World War II, German engineers developed the V2 rocket. The V2 was a terrifying weapon. It could travel enormous distances at incredible speed. It was the world's first long-range guided ballistic missile. And after the war, the United States and Soviet Union realized something important. If you can build a rocket powerful enough to send a weapon across continents, you can potentially build one powerful enough to send something into space, a satellite, a scientific instrument, maybe even a human. And this is where the Cold War and the space race collide. In 1957, the Soviet Union shocked the world. They launched Sputnik. Sputnik was the first artificial satellite. It wasn't huge, it wasn't complicated by modern standards. It was basically a metal sphere with antennas, but it was orbiting Earth. Humanity had put a machine in space, and Sputnik sent out a radio signal. Beep, beep, beep. That's it. But imagine hearing that in 1957. You're sitting in your house, the Cold War is happening, nuclear weapons are terrifying the world, and suddenly you hear a radio broadcast telling you that a Soviet machine is passing overhead. Now that little beep wasn't just a scientific achievement, it was a message. We can reach space. And the United States immediately realized that the Soviet Union had a serious technological advantage. The space race was on, and then the Soviet Union did something even more dramatic. They sent a living creature into orbit. Her name was Laika. She was a Soviet dog. Laika became the first animal to orbit Earth. Her story became famous around the world, but it's also tragic. Her spacecraft was never designed to return her safely to Earth. For decades, Soviet officials claimed she survived for several days before being peacefully euthanized. Later information showed that she died only hours after launch, probably because of overheating and stress. Her mission helped demonstrate that living organisms could survive the launch and conditions of spaceflight, but Laika never came home. Her story remains one of the most uncomfortable chapters of the early space race, because exploration has always come with a difficult question. How much risk are we willing to accept to discover something new? And soon, humans were going to answer that question for themselves. On April 12th, 1961, a young Soviet cosmonaut named Yuri Gagarin climbed into a tiny spacecraft. He was 27 years old. His spacecraft was called Vostok 1. the rocket launched, and Gagarin became the first human to travel into space. He completed one orbit of Earth. The entire flight lasted about 108 minutes, just under 2 hours. But think about what those 2 hours meant. Nobody had ever done this before. Nobody knew exactly how a human body would respond to space. Nobody knew how the spacecraft would behave, and there was no rescue team waiting nearby. Gagarin was alone inside a machine sitting on top of a giant rocket. And then suddenly, he was above Earth. For the first time in human history, someone was looking down at our planet from space. He could see the Earth as one world, no borders, no countries, no political divisions visible from that height, just a blue planet surrounded by darkness. And there's a funny little detail about Gagarin's flight. The spacecraft was not designed to land with him still inside. Near the end of the mission, Gagarin ejected from the spacecraft and parachuted separately to Earth. So the first human space flight technically ended with the world's first astronaut jumping out of his spacecraft. Not exactly the smooth, elegant space travel we see in movies. The Americans were now determined to catch up. A few weeks later, Alan Shepard became the first American in space. His flight lasted only about 15 minutes. He didn't orbit Earth. He went up and came back down. But it was enough to prove that the United States could send humans into space too. Then President John F. Kennedy made an announcement that sounded almost impossible. The United States would send a human to the moon and return them safely to Earth before the end of the decade. At that point, America had barely begun human spaceflight. Now they were announcing that humans would travel roughly 384,000 kilometers to another world. They would have to land there, walk around, take off again, return to Earth, and somehow survive the whole thing. The computers they would use would be laughably weak by modern standards. Your phone has vastly more computing power, your smartwatch has more computing power, your car probably has more computing power, and yet these primitive computers would eventually help humans land on the moon. But before we get there, NASA experienced one of the worst disasters in its history. In 1967, astronauts Gus Grissom, Ed White, and Roger Chaffee were conducting a ground test inside the Apollo 1 spacecraft. A fire started. The cabin was filled with pure oxygen at high pressure. Within seconds, the spacecraft became an inferno. All 3 astronauts died. The tragedy forced NASA to completely rethink parts of the spacecraft and its procedures. It was a devastating reminder that the moon landing wasn't guaranteed, people could die, the spacecraft could fail, the entire program could collapse, but NASA continued. And in December 1968, Apollo 8 became the first crewed spacecraft to travel to the moon and enter lunar orbit. The astronauts weren't landing yet, they were circling the moon. But they were farther from Earth than any humans had ever been. And then something happened that would become one of the most famous moments in space photography. The astronauts saw Earth rising above the lunar horizon, a tiny blue world appearing above the grey moon. They took a photograph, Earthrise. It's difficult to explain how powerful that image was. For most of human history, we had thought about ourselves from the ground. We saw countries, borders, cities, mountains, oceans, but from the moon, Earth looked tiny, one world. And suddenly, the planet itself became the thing worth looking at. Then came July 1969, Apollo 11, Neil Armstrong, Buzz Aldrin, Michael Collins, the Saturn V rocket launched with enormous power. It carried 3 people toward the moon. Armstrong and Aldrin would land, Collins would stay in lunar orbit, and here's something that often gets overlooked. While Armstrong and Aldrin were on the lunar surface, Michael Collins was completely alone in lunar orbit. At certain points, he was the most isolated human being in history. If something went wrong with the lunar module, he couldn't simply go rescue them. If something went wrong with his own spacecraft, they couldn't easily rescue him. 3 humans, 2 spacecraft, 1 distant world. The lunar module began its descent, and things got tense. The computer began producing alarms. The planned landing area wasn't as safe as expected. Armstrong had to take more control himself. Fuel was running low, mission control was listening, and then came the words everyone remembers: the Eagle has landed. Humanity had landed on another world. Armstrong climbed down the ladder, his foot touched the lunar surface, and suddenly, a species that had spent thousands of years staring at the moon was standing on it. But here's something astronauts quickly discovered. The moon is dusty, very dusty, lunar dust is incredibly fine and abrasive. It got everywhere. It stuck to spacesuits. It got inside the spacecraft. And astronauts discovered that it smelled strange. When lunar dust was brought inside and exposed to air, astronauts described its smell as somewhat like burnt gunpowder. So humanity finally reached another world and immediately discovered that the place smelled like a fireworks factory. But the moon wasn't just dusty, it was also a great place for recreational activities, at least according to Alan Shepard. During Apollo 14, Shepard brought a golf club. He took a couple of swings on the moon. The first wasn't very impressive, the second went much farther. And because lunar gravity is only about 1/6 of Earth's, Shepard joked that the ball went miles and miles and miles. It didn't, but it was still probably the most expensive golf game in history. And then Apollo 13 happened. Apollo 13 was supposed to land on the moon. Instead, it nearly became a disaster. About 2 days into the mission, an oxygen tank exploded. The spacecraft was badly damaged. Power was disappearing. The lunar landing was abandoned. Now the mission had a new goal: get the astronauts home alive. Jim Lovell, Jack Swigert, and Fred Hayes moved into the lunar module. The lunar module had been designed to land 2 people on the moon. Now it had to keep 3 people alive, and it wasn't designed for that. Carbon dioxide started becoming a problem. The astronauts needed a way to use filters from the command module with the lunar module system. The problem, the connectors didn't fit, so engineers on Earth had to figure out how to connect 2 systems that were never designed to work together. They had limited materials. The astronauts had whatever was already inside the spacecraft. They couldn't send new equipment. They couldn't physically help them. So the engineers built an improvised solution and talked the astronauts through it, and it worked. The spacecraft eventually swung around the moon and headed back toward Earth. The crew survived. Apollo 13 became one of the greatest examples of human improvisation in the history of engineering. They didn't accomplish what they planned. They didn't land on the moon, but they did something arguably more important. They got everyone home. And then after Apollo 17 in 1972, humans stopped going to the moon. That's right, we landed people on the moon 6 times, 12 humans walked on its surface, and then we stopped. The last humans left the moon in December 1972. The last person to walk on the moon was Harrison Schmitt. And since then, the moon has been sitting there, just 384,000 kilometers away, waiting. Meanwhile, NASA moved on to the Space Shuttle. The shuttle looked like something from science fiction. It launched vertically like a rocket, then returned to Earth like an airplane. It could carry astronauts and cargo. It helped build the International Space Station. But the shuttle was much more complicated to maintain than people initially hoped. It wasn't simply a reusable airplane. Each mission required enormous amounts of inspection and preparation. And the shuttle program also suffered 2 catastrophic disasters. Challenger broke apart shortly after launch in 1986. Columbia was destroyed during re-entry in 2003. Together, the disasters claimed 14 astronauts. Once again, space exploration reminded us that the universe doesn't care how confident we are. You can spend years designing something, you can test it, you can calculate everything, and something you didn't expect can still go wrong. But perhaps one of the greatest examples of human engineering isn't a rocket, it's a telescope. The Hubble Space Telescope launched in 1990. Scientists expected incredible images. Instead, they discovered a horrifying problem. The telescope's main mirror had been manufactured incorrectly. The error was microscopic, only a couple of microns, but it was enough to make Hubble's images blurry. Imagine spending years building one of the most sophisticated telescopes ever created, launching it into space, and then discovering, oops, Hubble couldn't simply be brought back to the factory. It was in orbit, so astronauts had to repair it. They installed corrective equipment, and suddenly, Hubble worked. The images it sent back changed astronomy and popular culture. Nebulae, galaxies, stars being born, galaxies billions of light years away. Hubble allowed ordinary people to see the universe in a way that had previously been almost impossible. And while Hubble was looking outward, humans were building something in orbit the International Space Station, the ISS, was constructed piece by piece in space. Astronauts and cosmonauts from different countries have lived and worked there for months at a time. And living in space is weird, really weird. For starters, there's no normal floor. You sleep inside a sleeping bag attached to a wall. You don't really need a bed. You just need something that keeps you from floating around while you're asleep. Food doesn't behave normally. Water doesn't behave normally. Even tears don't behave normally. On Earth, if you cry, gravity pulls the tears down your face. In microgravity, tears can form little blobs around your eyes. Imagine trying to have an emotional moment and accidentally getting a floating water bubble stuck to your face. Astronauts also have to exercise for hours because the human body doesn't like living in microgravity. Muscles weaken, bones lose density. Your body basically starts saying, apparently gravity is optional now, and there's another problem: the bathroom. Space toilets are engineering marvels because normal plumbing depends heavily on gravity. So spacecraft use airflow and carefully designed systems to move waste. And yes, space toilets have broken because apparently even after humanity conquered orbital mechanics, we still couldn't completely conquer plumbing. But perhaps one of the strangest things humans have sent into space is the Voyager spacecraft. Voyager 1 and Voyager 2 launched in 1977. They were sent to explore the outer planets, Jupiter, Saturn, Uranus, Neptune. They sent back incredible data, but they carried something else, a golden record, a message from Earth. It contained sounds, music, greetings, and images representing our planet. It's basically a message in a bottle, except instead of throwing the bottle into the ocean, we threw it into the galaxy. The odds that an alien civilization will ever find it are incredibly small, but that isn't really the point. It's a statement, a little cosmic introduction. Hello, we're from Earth. This is what our planet sounds like. This is what we look like. This is what we know. And Voyager kept going long after its original mission was supposed to end. Engineers have had to shut down systems, conserve power, and find creative ways to keep the spacecraft functioning. And here's the incredible part. Voyager is now so far away that communicating with it takes many hours. Imagine troubleshooting your laptop, except your laptop is billions of kilometers away. You can't touch it, you can't replace anything, you can't press the reset button. You send a command, then you wait and hope. And somehow engineers have kept these machines alive for decades. And while we're talking about strange things in space, we need to talk about planets. Because once astronomers started discovering planets around other stars, things got weird very quickly. We found planets orbiting incredibly close to their stars. Some have years that last only a few days. Imagine living on a planet where Monday morning happens, and by Friday, you've completed an entire year. Some planets are so close to their stars that they're being blasted by enormous amounts of radiation. Some are giant gas planets, some are probably rocky, some may have oceans, and some exist in places astronomers didn't expect planets to exist. The universe keeps doing this. We make a theory, the universe says, interesting theory, and then it produces something that doesn't fit. Black holes are perhaps the ultimate example. For a long time, black holes were mainly mathematical ideas. Objects with such extreme gravity that nothing could escape, not even light. That means you can't simply look at a black hole, it's dark. So astronomers studied what black holes do to things around them. Stars orbit them, gas gets heated to enormous temperatures, light bends around them, and eventually, scientists obtained increasingly strong evidence that black holes were real. Then in 2019, humanity saw something extraordinary. Scientists produced the first image of a black hole's shadow. It was the black hole at the center of the galaxy Messier 87. The black hole is billions of times more massive than the sun, and to photograph it, scientists essentially used telescopes around the Earth as one giant telescope. The image wasn't a photograph in the traditional sense. It was the result of enormous amounts of data gathered by telescopes around the world and processed using sophisticated techniques. And finally, there it was, a dark center surrounded by a glowing ring, a black hole something so strange that even light can't escape its gravitational grip, and humanity had managed to see its shadow from billions of light years away. But perhaps the strangest thing about astronomy isn't black holes, it's time, because when you look into space, you're looking into the past. The moon is about 1.3 light seconds away. So when you look at the moon, you're seeing it as it was about 1.3 seconds ago. The sun is about 8 light minutes away. So when you look at the sun, you're seeing it as it was about 8 minutes ago. If you look at a star 100 light years away, you're seeing that star as it looked 100 years ago. And if you look at a galaxy a billion light years away, you're seeing it as it looked a billion years ago. The night sky is basically a time machine. Every point of light is a message from the past. Some of those stars may have changed dramatically since their light began traveling toward us. Some may no longer exist. But their ancient light is still arriving. And then there's the biggest discovery of all. The universe is expanding. Not just galaxies moving through space. Space itself is expanding. The universe began in a hot, dense state roughly 13.8 billion years ago, and it's been evolving ever since. Stars formed, galaxies formed, planets formed, eventually Earth formed, life appeared, and after billions of years, one species on one planet became capable of looking at the stars and asking questions about them. Think about how bizarre that is. The universe existed for billions of years before humans appeared. Stars were being born, galaxies were colliding, planets were forming, and then eventually on one tiny rocky planet, matter became capable of wondering where it came from. That's us, and we still don't know whether we're alone. We've discovered thousands of planets orbiting other stars. Some are in regions where temperatures might allow liquid water. Some may have atmospheres, some may have oceans, and somewhere out there could be life, maybe microscopic, maybe complex, maybe intelligent, or maybe Earth is incredibly rare. We don't know. And honestly, that uncertainty might be the most exciting part, because the story of space exploration isn't finished. We're still at the beginning. There are worlds we haven't visited, stars we haven't studied closely, planets we haven't even discovered yet, questions we haven't thought to ask. Maybe humans will return to the moon, maybe we'll build permanent bases there, and maybe humans will eventually travel to Mars. Maybe we'll find evidence that Mars once had life. Maybe we'll discover life beneath the ice of an ocean moon. Maybe a telescope will find a planet with an atmosphere that contains chemical evidence of biology. Maybe we'll detect a signal from another civilization, or maybe we won't. But regardless of what happens, there's something remarkable about the fact that we're even asking. For thousands of years, humans looked at the sky and saw gods, omens, spirits, and mysteries. Then we built mathematics, we built telescopes, we built rockets, we built spacecraft, we built robots, we built laboratories in orbit, we walked on another world, we sent machines beyond the planets, and now we're looking farther than ever before. The universe hasn't gotten smaller as we've learned more, it's gotten bigger. Every answer has revealed another question. We discovered that Earth is a planet, then we discovered that the sun is a star, then we discovered that the sun is one star among hundreds of billions in the Milky Way, then we discovered that the Milky Way is just one galaxy among potentially hundreds of billions or even trillions of galaxies in the observable universe. And every time we thought we had reached the edge of the map, someone discovered another continent, another ocean, another galaxy, another mystery. Maybe that's why space has fascinated us for so long. It's not just because it's beautiful, it's because space reminds us how much we don't know. And maybe that's a good thing. Because imagine a universe where we already knew everything. No mysteries, no unexplored worlds, no questions, no reason to build another telescope, no reason to launch another spacecraft, no reason to wonder. That universe would be a lot less interesting. Instead, we live in a universe where a tiny blue planet circles an ordinary star in an ordinary galaxy, and somehow the creatures living on that planet have figured out how to look billions of light years into the past. We've made machines that can travel between planets. We've sent robots across Mars. We've built telescopes capable of seeing galaxies from the early universe. We've landed humans on the moon. and we've sent a message from Earth drifting into interstellar space. All because one day someone looked up. So the next time you walk outside at night, take a moment, look at the moon, look at the stars, look at that little moving light crossing the sky. Remember that some of those photons have been traveling for hundreds, thousands, millions, or even billions of years just to end their journey in your eyes. Remember that the atoms in your body were created inside ancient stars. Remember that the calcium in your bones, the oxygen you breathe, and many of the elements around you were forged through cosmic processes that began long before Earth existed. In a very real sense, you are made of ancient space history, and that means something extraordinary. The universe isn't just something we're observing from the outside. We're part of it. We are made from it. And after billions of years of stars being born, exploding, colliding, and transforming, the universe eventually produced something that could look back at the stars and say, wow. And maybe that's the strangest fact about space of all. Not that there are black holes, not that there are billions of galaxies, not that the universe is expanding, not even that humans have walked on the moon. It's that in this enormous ancient universe, we are here. We're curious, we're asking questions, we're building machines, we're looking outward, and we're still trying to figure out where we came from and what's waiting out there. The story of space isn't finished, it's barely begun, and somewhere beyond the edge of what we can currently see, the next unbelievable discovery is already waiting. We just haven't looked far enough yet.